we videoing? Okay, so what we have here is just ordinary salinity seawater. This is exactly the same stuff as is in this tank. This is just typical marine seawater. Okay, so what we have in here, I haven't actually opened the buckets to check, so I hope Louise has done it right. Okay, oh look at that. What we have here is 3 times concentrated seawater, and in it there's a harmless fluorescent dye. It's for you. So this needs to be poured through the funnel. No, funnel on the bottom.
Oh, sorry.
We need layers. Right, pour quite slowly and steadily. Yeah. Now, because this is 3 times concentrated, this is going to be more dense than the ordinary seawater. There's 3 times as much salt in it, so it'll be a lot heavier. And very good. Keep your funnel there. And if you can see, you can come right in with a video camera and bend down and have a look. What we should see here, no, from the side so we can see the layers. Do we have layers? Can anyone see? Have we got some stratification?
Yeah.
So the denser water that's more salty has formed a layer under the other one. Right? And finally what we've got is some even more salty water that's dyed red. Again, just the food colouring. And now we need, who's our other bucket volunteer? So again, put the funnel right the way through. And then you need to carefully see if you can get another layer. So the dye isn't making this separate, it's the differences in density, the differences in salinity. And I call this shrimp cocktail because the same principle would hold if you were making a cocktail. So you'd get the more sugary liqueur that was more concentrated and... Oh, is that going alright? Sort of. It's kind of mixing with the other layer. Can we stop there actually? I think there's perhaps a bit more of that than there was supposed to be.
That looks fine.
Does that look
yeah,
fine?
Yeah, stop there, that looks fine. Yeah.
Yeah, is that okay? Right.
If you bend down, you can see. Yeah, you can see.
Oh yeah. Oh, that's worked quite well. So if you were making a cocktail, you can do something similar. You would start off with your less dense, lighter spirit, like tequila or vodka, and then you can pour something, a thicker, more sugary liqueur of a different colour. You can carefully pour that down the side of the glass. It'll settle underneath, and it'll form that sort of stratification, the different coloured stripes, because the differences in density. So that's exactly what we've done here. We've got our 5 times concentrated seawater, which is red, our 3 times concentrated seawater that's green, and our ordinary seawater at the top that's clear. So let me move these buckets out of the way. And then where was our shrimp catching volunteer? That was you, wasn't it? Okay, right, let me just move these buckets and let's bring our shrimp over here. So, apart from the colours, this is quite a natural thing for Crangon to have to deal with. In a rock pool environment, on a hot day, there could be areas where the water evaporates and it becomes really concentrated and more salty. And so the shrimp are used to making salinity choices about what the optimal environment is. So do you want to catch a shrimp? They're quite quick. Yeah, and then we'll put the hand over because they jump a bit, and then let's just tip him. In he goes. So, there's Mr. Crangon in his shrimp cocktail rock pool. And the normal behaviour for one of these shrimp, particularly when they've been captured in a net, they think there's a predator after them, they would normally go to the bottom of the rock pool and hide in the darker places against the substrate. So what's the shrimp doing? It's clearly, by swimming on the surface, he's putting himself at risk of predation. But what it looks like to me is that he's actually choosing to swim quite hard to stay in that top layer near the surface. Can you see that? You can come up and have a look if you want. Do you all believe me? Okay, so he's clearly choosing that top layer. So who's got our salinity probe? Let's see if we can get this switched on. It should really have been kept in some water. Let's get it switched on. And see if we can get it reading in the right units. Right.
So we designed a little ladder that we thought crabs would crawl up. And then maybe somebody could do that for their honours project, look at nitrates and phosphates, temperature differences, pH differences, using this one.
Because this is true. I mean, although we're talking about osmoregulation, there's all sorts of other environmental parameters that animals will exhibit sort of migratory behaviour to keep away from or go towards. All sorts of different chemical cues. Right, so where's our salinity probe expert? So, here you are. Right, basically, what I would like you to do is dip this in the top layer, the very top layer, where the shrimp is enjoying hanging out, and then... Right, so what we've got there, we've got a reading of 33 or 34 parts per thousand. So that seems to be the salinity that the shrimp is choosing. And then can you just move that down to sort of the green layer? Are we in the green layer? Or have we gone a bit far?
I need to walk a bit.
Okay, right, so now we're getting a reading of about 50 parts per thousand. And then can we go right the way to the bottom? And just lift it up a bit. And it's not actually reading anything there. We had this last week. I don't know if that's just too salty for the machine to read.
Okay.
Should it be okay? Do you want to come and fiddle with this?
Well, I shall have to ask the technician.
It's
probably
as well. Unless it's just the scaling.
Yeah.
But I think the take-home message is that when given the choice of different salinities, Krangon likes the salinity of about 33 parts per thousand, and that is
75.
75 on the bottom. So he's had a choice of 33, 50 and 75, and he's clearly choosing to hang out where it's 33. And that's that's optimal for him. We can assume that's about what his blood salinity is, and he's clearly wasting a lot of energy in swimming and putting himself at risk of predators by being in that very top layer. So clearly it must be quite energetically expensive to have to physiologically osmoregulate, and if you can behaviourally osmoregulate, it's probably an energetic trade-off worth making. Okay, are we all now convinced about behavioural osmoregulation? Okay, do you think we can catch Mr. Shrimp and put him back with his friends? Oh, you might jump, so be ready with your hand.
Nope.
Yep, back in here. Is he in there? Right. Okay, so yeah, he's absolutely fine. You needn't worry about him at all, apart from the funny colours and the fact he'll go home with a story of alien abduction and scary green lights. Then apart from that, this is quite a natural thing for Krangon to have to deal with, albeit 5 times in a row, because that's how many times we're in this class. Okay, so you can stop videoing now.